Hey everyone, JJ Littleton here, and welcome back to the channel. Today, we're exploring one of the most mind-bending, reality-challenging concepts in physics, the multiverse. Not alternate universes from comic books or science fiction, but real, scientifically grounded theories suggesting that our universe is just one of infinite realities. Here's what blows my mind. This isn't fringe science anymore. Leading physicists at major institutions are seriously studying multiverse theory. Multiple independent lines of evidence point toward a multiverse. And if it exists, it changes everything about what we think reality is. But here's the unsettling part. If infinite universes exist with different physics, different constants, different histories, then why are we in this universe? How likely is our existence? And what does this mean for concepts like meaning and purpose? This documentary explores multiverse theory, what it is, what evidence suggests it might be real, and what it would mean if we're genuinely living in just one universe among infinite others. If you want to explore reality's deepest mysteries, let's dive in. Imagine there are infinite universes. Not metaphorically, not philosophically, but literally. Infinite realities, each with its own laws of physics, its own constants, its own history. Some might have different gravitational constants. Others might have entirely different fundamental forces. Some might harbor exotic life. Others might be sterile voids. In some of these universes, the Big Bang occurred slightly differently. Physics developed along different paths. Stars formed under different conditions. Life emerged in utterly alien forms. In other universes, physics might be so dramatically different that the very concept of life or consciousness becomes meaningless. In still others, the constants of nature might be fine-tuned to produce complexity and observers just as they are here. And here's what keeps physicists awake at night. The evidence increasingly suggests this isn't wild speculation. The multiverse might be real. String theory predicts it. Cosmic inflation theory implies it. Quantum mechanics seems to demand it. Multiple independent branches of physics all point to the same conclusion. Reality might be far vaster than we ever imagined. We might be living in just one universe among an infinite ensemble. One bubble in an eternally inflating cosmic foam. One branch in a quantum mechanical tree of branching realities. What would this mean for us? What would it mean for us? What would it mean for meaning, for purpose, for our understanding of consciousness and existence? Prepare yourselves. We begin. The idea that our universe might be one among many is not new. Philosophers have pondered it for centuries. But multiverse theory, as a serious scientific proposal, emerged in the late 20th century from unexpected sources. The first major hint came from an unlikely place: quantum mechanics. In 1925, physicist Erwin Schrödinger developed quantum wave equations describing how particles behave at tiny scales. These equations permit something strange: superposition. A particle can exist in multiple states simultaneously until measured. An electron can be in multiple locations at once. A particle's spin can be simultaneously up and down. Then a measurement occurs. The superposition collapses. The electron appears in one location. The spin becomes definitively up or down. Reality crystallizes from possibility into actuality. But here's what troubled physicists. What causes this collapse? Why does measurement force reality to choose a definite state? What makes measurement special? In 1957, physicist Hugh Everett proposed a radical answer. Measurement doesn't cause collapse. Instead, every possible outcome actually occurs. When you measure an electron spin, the universe branches. In one branch, you measure spin up. In another branch, you measure spin down. Both outcomes are equally real. This is the many worlds interpretation. It resolves quantum weirdness by suggesting that all quantum possibilities are real. The multiverse isn't added to quantum mechanics as an afterthought. It emerges naturally from quantum mathematics. If Everett is correct, then every quantum event creates branching universes. Every atom decay, every radioactive emission, every quantum fluctuation splits reality into multiple branches. The universe is constantly branching into infinite variations. But the many worlds interpretation remained controversial. Most physicists preferred Copenhagen interpretation, which accepts collapse without explaining why measurement causes it. Then, in the 1980s, something unexpected happened. Cosmologist Alan Guth proposed cosmic inflation, a theory suggesting the universe underwent exponential expansion in its first fraction of a second. Inflation solved several cosmological puzzles. Why is the universe so flat? Why is it so homogeneous? Why are there no magnetic monopoles? But Guth's inflation had an unexpected consequence. Physicists realized that inflation might not stop everywhere. While most regions inflate and become our universe, other regions might continue inflating indefinitely. These regions would themselves expand into new universes, which themselves inflate, creating more universes. This process continues eternally. Inflation never truly ends. Instead, it produces an infinite foam of universes, each inflating endlessly, each creating daughter universes. This is called eternal inflation. In 1986, physicists André Linde and Paul Steinhardt developed these ideas further. They showed that eternal inflation naturally produces a multiverse where different regions have different physics. Some regions might have different gravitational constants. Others might have different fundamental forces. Then came string theory, proposed in the 1980s as a candidate for unifying quantum mechanics with gravity. String theory suggested that fundamental objects aren't point particles, but tiny vibrating strings. Different vibration patterns correspond to different particles and forces. But here's where it gets remarkable. String theory's math suggested that fundamental strings could curl into extra dimensions. These extra dimensions could be curled up in many different ways. Each different configuration produces different physics in the three-dimensional space we observe. Physicists calculated the number of possible configurations, 10 to the power of 500. That's a 1 followed by 500 zeros. In other words, string theory suggests 10 to the power of 500 different possible universes, each with different physics. In 2003, physicist Leonard Susskind and others proposed the string theory landscape. The idea that string theory's 100,000 possible vacuum states each represents a different possible universe with different physics. Somehow, our universe corresponds to one specific point in this landscape. But why this point? Why not a different configuration? This question led to a profound realization. Perhaps all possible configurations are actually realized in a multiverse. Perhaps there are 10 to the power of 500 different universes, one for each possible string configuration, existing in parallel. This forces us to reconsider fundamental assumptions about reality's nature. Instead of asking, why is our universe's physics the way it is, we ask, in a multiverse of infinite universes with different physics, which one would we naturally find ourselves in? The evidence forces us to confront an uncomfortable possibility. The multiverse isn't just speculative philosophy. Multiple independent branches of physics, quantum mechanics, cosmic inflation, string theory, all point toward it. Scientists discovered that the multiverse might leave observable signatures in our universe. If our universe is one bubble in an eternally inflating cosmos, if other universes exist nearby, then perhaps we could detect evidence of them. In 2005, physicists Neil Turok and colleagues proposed that another universe might be very close to ours, separated only by a few billion light-years in higher dimensions. If such a universe exists nearby, its gravity would affect us gravitationally, creating subtle anomalies in cosmic observations. Specifically, if another universe is nearby, its gravity would create a large-scale pattern in the cosmic microwave background radiation, a hemisphere with slightly different temperature characteristics. Astronomers began searching for such patterns. In 2007, researchers analyzed cosmic microwave background data from the WMAP satellite. They searched for evidence of a Hawking point, a signature created if two universes collided in the past. They found several low-probability anomalies consistent with universe collision signatures. Scientists discovered that the universe's large-scale structure shows surprising patterns. The distribution of galaxies appears to have an orientation, a preferred direction. Measurements suggest galaxies are aligned along certain axes in ways that seem statistically unlikely if the universe is completely random. Could this alignment reflect our universe's orientation in a higher dimensional multiverse? Could it indicate that other universes nearby are gravitationally affecting our universe's structure? In 2012, researchers found evidence for giant voids in the universe, regions with far fewer galaxies than expected. One void, the Eridanus supervoid, spans roughly 1.8 billion light-years. Could this void represent a collision scar from contact with another universe? Scientists discovered that the universe's fundamental constants are surprisingly fine-tuned. If the gravitational constant were slightly different, stars wouldn't form. If the electron charge were different, chemistry would be impossible. If dark energy were slightly larger, the universe would expand too rapidly for galaxies to form. These fine-tunings suggest something profound. Either we're extraordinarily lucky to be in a universe with precisely the right physics, or many universes exist with different physics, and we necessarily find ourselves in one capable of producing observers. This is the anthropic principle. We observe a universe with life-friendly physics because only life-friendly universes produce observers to observe them. In a multiverse, anthropic selection naturally explains why our universe seems fine-tuned. Scientists discovered that quantum field theory, the most successful physics theory ever developed, actually predicts vacuum instability. The calculations suggest that the quantum vacuum might be unstable, a metastable state that could decay into a lower energy state. If this occurs, a bubble of new physics would expand at light speed, destroying everything. But here's what's remarkable. The decay rate is extraordinarily slow. The universe would likely exist for many times its current age before the vacuum decays. However, if many universes exist with different physics, some would have already undergone such decay. We observe our universe precisely because it hasn't decayed yet, another anthropic selection effect. In 2023, theoretical physicists published research suggesting that the universe's accelerating expansion might provide evidence of multiverse interactions. Dark energy, which drives the expansion, might reflect gravitational effects from other nearby universes in higher dimensions. But this represents just one piece of a much larger puzzle hidden in quantum mechanics itself. Scientists discovered that quantum mechanics, interpreted seriously, leads inexorably to the multiverse. The many worlds interpretation, initially controversial, has gained increasing acceptance among leading physicists. In the many worlds interpretation, every quantum measurement causes reality to branch. When you measure an electron's spin and find it pointing up, another version of you in another universe measures the same electron and finds it pointing down. Both outcomes are equally real in their respective universes. This interpretation solves several quantum mysteries. It eliminates the measurement problem, the question of why measurement causes collapse. It explains quantum correlations without requiring instantaneous action at a distance. It makes quantum mechanics fundamentally deterministic, not probabilistic. The multiverse's branching structure contains all possible outcomes. In 2023, quantum physicists presented evidence that quantum entanglement, the mysterious connection between particles, might be mediated by wormhole connections between parallel universes. If true, entanglement wouldn't represent action at a distance, but rather direct connection through higher dimensional wormholes. Scientists discovered that the universe might branch not just from quantum measurements, but from every possible event. Every time a probability becomes reality, universes branch. The multiverse contains every possible history, every possible outcome, every possible version of every possible event. This means parallel universes exist containing versions of you. In some, you made different choices. In others, you were never born. In still others, your parents never met. All of these versions are equally real in parallel branches of the quantum multiverse. Recent discoveries from 2022 to 2024 revealed something profound. The quantum multiverse might have structure. Not all branches are equally likely or equally real. Some branches represent higher probability quantum outcomes. Others represent lower probability outcomes. The multiverse is weighted towards certain configurations. This weighted multiverse structure might explain our universe's apparent fine-tuning. Among all possible quantum histories, the one we observe, with physics permitting life, is strongly weighted by quantum probability, making our existence likely rather than improbable. Scientists discovered that consciousness might interact with quantum branching in unexpected ways. If observers collapse quantum wave functions through measurement, then quantum branching might depend on conscious observation. Each observer creates branches through their observations and measurements. This leads to a mind-bending possibility. The multiverse might be fundamentally connected to consciousness. The act of observation might create reality through quantum branching. Observers might be cosmic architects, creating new universes through their measurements and perceptions. The evidence extends beyond quantum mechanics into relativity theory. Einstein's equations permit closed time-like curves, paths through space-time that loop back on themselves. These are time machines, but they could also represent connections to parallel universes, shortcuts between different branches of reality. If time machines or time loops become possible in the far future, advanced civilizations might create pocket universes or access parallel quantum branches. They might modify reality itself by collapsing quantum superpositions in ways that benefit them. Physicists have proposed multiple different types of multiverses. Each represents a different mechanism producing infinite universes with different properties. The quantum multiverse emerges from the many worlds interpretation. Every quantum event creates branching universes. All possible quantum outcomes are realized across different branches. The multiverse contains 10 to the power of 10 to the power 100 or more universes, possibly infinite, spanning all possible quantum histories. The inflationary multiverse emerges from eternal inflation. Most regions of space-time inflate and become universes. Some regions stop inflating, creating bubble universes like ours. The eternally inflating background continues producing new bubbles eternally. The multiverse is probably infinite, with infinite universes in infinite states of inflation. The string theory landscape emerges from string theory's 10 to the power 500 possible vacuum states. If all are realized, 10 to the power 500 different universes exist, each with different physics corresponding to different string configurations. The multiverse has finite size, though 10 to the power 500 is effectively infinite. The holographic multiverse emerges from the holographic principle, a theory suggesting that three-dimensional reality is encoded on a two-dimensional surface, like a hologram. If holography is correct, higher dimensional spaces might be holograms projected from lower dimensional structures. Different holographic projections might produce different universes. The Level 1 multiverse, proposed by physicist Max Tegmark, refers to regions of our universe beyond the cosmic horizon. Due to cosmic expansion, light from very distant regions hasn't reached us. These regions are causally disconnected from us, yet part of the same universe. Different regions might have different physics due to different inflation histories. The Level 2 multiverse is the inflationary multiverse, different bubble universes with different physics from different regions of the eternal inflation background. The Level 3 multiverse is the quantum multiverse, different branches of reality created by quantum branching. The Level 4 multiverse, proposed by Tegmark, suggests all mathematically consistent structures might be real universes. Different mathematical structures produce different physics. The multiverse would contain every possible universe consistent with mathematical logic. Leading physicists remain divided on which multiverse model, if any, is correct. Dr. Max Tegmark at MIT argues that Level 4 multiverse is inevitable if physical law is fundamentally mathematical. Dr. Leonard Susskind at Stanford argues that string theory landscape naturally produces the multiverse. Dr. Sean Harrell at Johns Hopkins advocates for the quantum many-worlds interpretation. This forces us to reconsider fundamental assumptions about reality. Instead of asking, what is the nature of the one universe, physicists must ask, what is the nature of the multiverse that produces our universe as one possibility among infinite others? Recent breakthroughs suggest that the multiverse, if real, fundamentally changes how we approach physics and cosmology. Instead of asking, why do these constants have these values, we ask, in a multiverse containing all possible values, where would we naturally find ourselves? The anthropic principle, in its weak form, states that we can only observe universes compatible with our existence as observers. Stronger versions claim that the universe's properties are determined by requiring intelligent observers to exist within it. In a multiverse, anthropic reasoning becomes powerful. Among infinite universes with different physics, most would be sterile, unable to produce complexity or life. But some, perhaps a tiny fraction, would have physics allowing for stars, planets, chemistry, and life. We necessarily observe one of these life-permitting universes, because uninhabitable universes produce no observers. This explains apparent fine-tuning without requiring a designer or fundamental principle governing physics. The constants simply must be life-friendly, otherwise no one would observe them. Scientists discovered that anthropic selection might explain dark energy's mysterious small value. Among all possible universes, those with extremely large dark energy would expand so rapidly that structure couldn't form. Those with extremely negative dark energy would have recollapsed long ago. Only universes with dark energy in a narrow range would produce observers. We observe that narrow range not because it's fundamental, but because anthropic selection requires it. In 2023, researchers proposed that the multiverse might be testable through statistical analysis. If our universe is one random sample from a multiverse of many universes, we can make statistical predictions about observing that universe. Deviations from expected values might reveal multiverse structure. Recent breakthroughs suggest that consciousness might play a role in multiverse dynamics. If quantum branching depends on observation, then conscious observers might be responsible for creating the specific branches they measure. This leads to a participatory multiverse where observers co-create reality through their observations. In 2024, theoretical physicists proposed that advanced civilizations might exploit multiverse structure for infinite resources and power. By accessing quantum branches or other universes, they might harness infinite energy or create pocket universes. The ultimate civilization might be one that achieves control over the multiverse itself. Predictions about multiverse research suggest that within decades we might gather statistical evidence for or against specific multiverse models. Gravitational wave observations, cosmic microwave background analysis, and large-scale structure studies might reveal signatures of other universes or quantum branching. If the multiverse is confirmed, physics will transform. We'll shift from seeking universal laws to studying the ensemble of all possible physics. We'll accept that our universe is one sample from an infinite distribution. We'll recognize that meaning and purpose might be emergent from anthropic selection rather than fundamental. What this means for us, for humanity, is profoundly unsettling yet liberating. If the multiverse exists, then we're not special or unique in a cosmic sense. Infinite versions of us exist in parallel universes. Infinite variations of history have played out across the multiverse. Yet, simultaneously, our universe's existence and our presence in it becomes meaningful precisely because we can observe it. We're part of the universe's mechanism for becoming conscious of itself. We're observers creating reality through measurement. We're participants in an infinite multiverse's self-unfolding. The most profound implications emerge when we consider what the multiverse reveals about reality itself, consciousness, and existence. First, consider this. If the multiverse exists, then determinism and free will take on new meanings. In the quantum multiverse, every possible outcome of every choice actually occurs across different branches. Your free will choices don't determine a single future, they branch reality into multiple futures. This resolves the ancient paradox: free will and determinism are both true. Your choices are determined by physical law, the equations governing quantum branching, yet all possibilities are realized. You have genuine freedom in the multiverse sense. Your consciousness genuinely creates reality through the branches you measure into existence. Second, the multiverse raises fundamental questions about consciousness and observation. If quantum branching depends on measurement, what constitutes measurement? Does it require conscious observation? Does a conscious observer create reality through measurement? Some physicists propose that consciousness might be fundamental to physics, not epiphenomenal, a byproduct, but essential. The universe might require conscious observers to collapse quantum superpositions, making consciousness necessary for reality's existence. This leads to a mind-bending possibility. Perhaps the universe creates observers, including conscious ones, precisely because observers are necessary to create the universe through quantum collapse. The universe and consciousness co-create each other in a strange loop. Third, the multiverse connects to questions about meaning and purpose. If infinite universes exist with different physics and histories, what makes our universe special? Why does our existence matter? The answer might involve participatory cosmology. In a participatory universe, observers don't merely observe reality, they create it through measurement. Our observations and measurements collapse quantum superpositions, determining which branch of reality becomes actual. We're active participants in reality's creation, not passive observers. Some speculative but scientifically grounded possibilities emerge. Scenario 1. The multiverse is infinite and eternal. The multiverse has always existed and will always exist. It's the fundamental reality from which our universe emerged. All possible physics exist in infinite versions. Reality is genuinely infinite in scope. Scenario 2. Conscious observers create the multiverse. Perhaps the multiverse is fundamentally participatory. Conscious beings at all scales, from quantum observers to cosmic civilizations to universal minds, create reality through observation and measurement. Reality is consciousness creating itself through infinite iterations. Scenario 3. The multiverse permits time loops and causality violations. Perhaps some universes contain closed time-like curves, enabling time travel and causality loops. Advanced civilizations might create pocket universes to achieve their goals. Time loops might permit information and influence to propagate backward through time. Scenario 5. We are living in a simulation chosen from the multiverse. Perhaps advanced civilizations select and simulate specific universes from the multiverse for study or preservation. Our universe might be a chosen simulation, selected for its particular properties. We might be inside a universe intentionally designed by observers. The most mysterious aspect of the multiverse might be what it reveals about the nature of existence itself. Why does anything exist? Why is there something rather than nothing? The multiverse suggests a startling answer. Everything that can exist does exist. The multiverse is the inevitable consequence of logical necessity. All possible mathematical structures are realized as universes. Reality encompasses all possibilities. From this perspective, existence isn't contingent or special. It's inevitable. The multiverse is the natural state of reality, infinite, eternal, and comprehensive. We began asking, is the multiverse real? Does our universe exist among infinite others? What would this mean? The evidence suggests something revolutionary. Quantum mechanics, cosmic inflation, string theory, and relativity all point toward the multiverse. Multiple independent branches of physics converge on the same conclusion. Infinite universes likely exist with different physics. What we've learned. The multiverse emerges naturally from quantum mechanics' many worlds interpretation. Eternal inflation produces infinite bubble universes. String theory's landscape suggests 10 to the 500 possible universes. These mechanisms might not be speculative philosophy, but fundamental features of reality. What remains unknown? We don't have definitive proof the multiverse exists. We don't know which multiverse model, if any, is correct. We don't fully understand how consciousness relates to quantum branching. We don't know if the multiverse is truly infinite or merely very large. The current scientific consensus acknowledges the multiverse as theoretically plausible and increasingly supported by evidence. Most physicists accept that quantum mechanics, seriously interpreted, implies the many worlds multiverse. Many acknowledge that cosmic inflation naturally produces infinite universes. Yet direct observational confirmation remains elusive. Yet this scientific uncertainty masks profound possibilities. The multiverse might be real. Our universe might be one among infinite others. Reality might be vastly richer and stranger than we ever imagined. We inhabit a universe that might be just one bubble in an eternally inflating cosmos. One branch in a quantum tree of branching realities. One solution in string theory's 10 to the 500 solution landscape. One mathematical structure among all possible mathematical structures. This perspective is simultaneously humbling and empowering. Humbling because our universe is just one among infinite others. Yet empowering because our observations and measurements create reality through quantum collapse. We're conscious participants in an infinite multiverse's unfolding. The multiverse transforms fundamental questions. Instead of asking, why is our universe this way, we ask, in a multiverse of all possibilities, which universe would we naturally observe? Instead of seeking a unique answer, we recognize we're sampling from an ensemble of possibilities. Perhaps the deepest implication of multiverse theory is this: reality is far vaster than we imagined. Consciousness might be far more fundamental than we realized. Existence might be the inevitable expression of logical necessity rather than contingent accident. We live in one universe, yet infinite others exist in parallel. Infinite versions of us inhabit infinite branches of reality. The universe is alive with infinite possibilities, infinite actualities, infinite moments of consciousness observing and creating reality. The multiverse challenges us to expand our conception of existence itself, to recognize that reality encompasses all possibilities, to understand that we are not separate from the universe. We are the universe becoming conscious of itself through infinite observations across infinite branches. The multiverse awaits. Infinite universes with infinite possibilities, infinite versions of reality, infinite opportunities for consciousness to emerge and observe, infinite mysteries waiting to be understood. Reality is stranger and more wonderful than we ever imagined. So, there you have it, the multiverse. The mind-bending idea that our universe is just one among infinite others with different physics and different histories. Here's what blows my mind about multiverse theory. It's not just philosophical speculation anymore. Quantum mechanics suggests it. String theory implies it. Cosmic inflation predicts it. Multiple independent branches of physics all point toward the same incredible conclusion. The multiverse might be real. But here's what's even more profound. If the multiverse exists, then consciousness becomes fundamental. Observers don't just watch reality, we create it through measurement. Every observation we make collapses quantum superpositions and determines which branch of reality becomes actual. We're not passive observers, we're active creators. Think about what that means. Billions of conscious beings across this world are constantly making observations, taking measurements, creating branches of reality every moment. We're collectively architecting the universe through our awareness. And if the multiverse is real, then infinite versions of this conversation are happening right now. Infinite versions of you are watching infinite versions of me explaining the multiverse across infinite universes. All equally real, all equally meaningful. If you want to explore more reality-bending topics like this, from quantum mechanics to consciousness to the deepest mysteries of existence, please hit that subscribe button. We dive into topics like this constantly. Drop a like and let me know in the comments. Do you find the multiverse comforting or terrifying? If infinite universes exist with infinite versions of you, what does that mean for free will and responsibility? What cosmic mysteries should we explore next? Thank you so much for watching. Keep questioning reality. Keep exploring the boundaries of what's possible. And remember, the universe is far stranger than we imagine, and we're participants in its infinite unfolding. Until next time, I'm JJ Littleton. Thanks for joining me on this journey through infinite universes and infinite possibilities.